In this lesson, we're going to have a look at a topic called addition of ordinates, right? Addition of ordinates basically can be taken into account when we have more than one function and we're trying to sketch both the function combined together in the form of an addition or a subtraction, right? Like, let's jump straight into this example. So they're saying use the addition of ordinates to sketch the graph of the following between the domain minus pi to pi, right? So the question given to us is y equals half cos 2 theta minus sine theta, right? So if I split this into two parts, right? So I have two functions here, right? I'm just going to call y1 as half cos 2 theta, right? I'm going to call y2 as sine theta, right? It's really important that we first analyze these two functions on its own before we combine them together into one function, like they've asked us to sketch in this particular question, right? So if I take into account y1 equals half cos 2 theta, I can see my amplitude is equal to a half, right? Now cos 2 theta will have a period of 2 pi divided by 2, which is equal to a period of pi units, right? At the same time, y2, in y2 the amplitude is a positive 1, and the period, because the value for n inside the bracket is 1, the period is going to be equal to 2 pi, right? So we just have a few challenges here. Obviously, y equals half cos 2 theta has a period of pi, and the y2 equals sine theta has a period of 2 pi. So obviously, these functions have different periods. Right, so let's go ahead and quickly sketch these functions individually in our graphing paper, right? So that's what I'm going to do first. So we're trying to sketch it between minus pi to pi. Now, the way I've always liked drawing sine and cos graphs is I like to draw them in quarters, right? So if I take into account my cos 2 theta, a quarter is going to be, the quarter of a period is going to be pi on 4 units. At the same time, if I take into account my sine theta graph, my quarter is going to be pi on 2, right? So 2 pi divided by 4 gives us pi on 2, right? So obviously looking at the denominators 2 and 4, lowest common multiple being 4, what I'm going to try and do is I'm going to try and split this graph into spaces of pi on 4 units. That's why it makes it easy for us to combine the period when it's necessary. All right, so let's start with sketching y equals half cos 2 theta, right? So I'm just going to mark some values on my Cartesian plane. So 0, right? So pi on 4, pi on 2, right? 3 pi on 4, and pi. Right, on the other side, because we're trying to sketch between minus pi and pi, we're going to do the same thing on the left hand side. Right, minus pi on 2, and minus pi, right? So in other words, what we're trying to do here is that particular distance is pi on 4 units for this particular scenario. Right? Now we also have two different amplitudes. The amplitude for the first one is a half, the amplitude for the second one is 1. So which means we need to be able to take both of that into account. So what I'm going to do is I'm going to go in terms of half on the y-axis, right? So that's going to be half, right? 1, right? 1.5. Right, similarly on the bottom, minus half, minus 1, and minus 1.5. Right, so that's probably what we would need because the amplitude is 1 and a half, right? We can combine them, could give us a maximum of 1.5 and a minimum of minus 1.5, right? So that's why we've gone to those two values on the y-axis, right? So let's start by sketching the very first graph, right? So I'm going to sketch y equals a half cos 2 theta in this particular section, right? So cos 2 theta is going to have a period of pi, so between minus pi and pi, we're going to be able to fit 2 cycles, right? So let's start with this. It's a positive cos graph, so starting at a half, right? The first quarter, right? The second quarter, third quarter, and the fourth quarter, right? So again, like I said, I like to draw my circular functions in quarters. Now, similarly, one period on the left hand side of the y-axis, right? 1 quarter, a second, a third, and then the fourth, right? So that way, what we've done is we've sketched y equals, so y1 equals a half cos 2 theta with the blue color, right? So I'm going to use a different color to sketch my y equals sine theta. Now sine theta's got a period of 2 pi, my bad, right? So which means a quarter is pi on 2 units. So which means I'm only going to be able to fit half a cycle on the right hand side of the y-axis because we only go in this particular question to a period of pi, right? So if we need to complete a full cycle, we need to be able to go till 2 pi. So that's what I'm going to do now. Right, so starting at 0 because it's a sine graph, a positive sine graph, right, a quarter is going to get me to 1. So that's going to be from there all the way to there, right, and then the second quarter, we're going to go back to 0 again, right, similarly on the left hand side, right, I'm going to go to -1 and back to 0 again. So all right, beautiful. All right, so now that we've sketched both the functions, we're going to combine them to the one function that's been asked to us in the question. The question is basically saying what is y equals a half cos 2 theta minus sine theta, right? Right. In other words, basically we're saying what is the blue graph, all right, which is my half cos 2 theta minus the green graph in this particular scenario, right? So let's start with the 0 on the x-axis, right? So at the 0 on the x-axis, right, my cos theta graph is equal to a half, and my sine theta graph is equal to 0. So a half minus 0 is going to give us a half. So that's going to be my very first point that I'm going to put. I'm just going to put some points before I even think of combining them with some values, right? So if I take into account this particular point here, right, where both the graphs are having the exact same value, right? If they have the exact same value and we subtract them, what are we going to end up getting? We're going to end up getting a 0, right? So which means I'm going to mark my next point at a 0, right? Now, if I take into account my next values, right, you can do a combination of points here, and that's going to really help get a good curve for this particular scenario, right? So again, a blue graph minus the green one, right? So if I take into account the next value, right, over here somewhere, right, my blue graph has a value of 0. Now 0 minus the green graph, which is having a value somewhere between a half and 1, right? So 0 minus that particular value is going to take us to a negative answer. So which means we're going to have a point somewhere here, right? Now we can keep going, right? I'm going to go straight to pi on 2. Pi on 2, the blue graph is a minus half. So minus half, take away positive 1. So that's going to take me to minus 1.5. So that's where my next point is going to be. Right, next I'm going to take this x-intercept for the blue graph, right, where it is 0. So 0 minus that value again, so which is going to give us a negative answer, right? And then if I take into account where the point of intersection is, right, both the values are the same, which means we're going to get to a 0, right? And then one final point at pi. If I take into account the value at pi, I'm going to have the blue graph has a value of a half, right? And the green one has a value of 0. So half minus 0 is equal to a half. So that's where it's going to complete the right hand side, right? Similarly, the left hand side is just going to follow pretty similar patterns here. But given that graph has different periods, it might not necessarily. So let's go one by one, right? So if I take into account my x-intercept for the cos function, the first x-intercept on the left side, so 0 minus somewhere between a negative half and minus 1. So 0 minus a negative number, right? That's going to lead us into a positive answer. So which means my point is going to be somewhere up here, right? So somewhere, no, not there, my bad. Right, my point is going to be somewhere up here. Right, and then the next value at pi on 2. At pi on 2, both the values are negative, right? So one's a negative half take away minus 1. So negative half take away minus 1 is going to lead us into a positive half, so which means that's where it's going to be. All right, the next one I'm going to consider at this particular point here, right, where the blue one is 0, so 0 minus a negative value between minus half and 1. Again, it's going to lead us into a positive answer, so somewhere there. Right, and one final point at minus pi. So minus pi, the blue one is a half, so half minus 0 is going to be half, right? So that's where we are, right? So now that we have, now you can do further points, right? You can even go further into the graph and see what works and what does not, right? So for example, if I take into account, right, it is good to do some further graphs further points if you want to be more accurate, right? I know, um, but I think at this stage, these values are kind of good enough at the moment. If you'd like. So again, we're trying to do blue minus green. So so if I take into account these 2 points here, so the blue graph just has a value of less than half, so a less than half minus um, minus of minus half. So that's going to take us a value close to positive 1. So like I said, it's really good to do further points into this particular scenario, right? So that way you can get more accurate graphing of your half cos 2 theta minus sine theta graph, right? And then, I can go further again. So a blue graph is somewhere between 0 and minus half, right? Take away a value that is double that, right? So that's going to basically, that's like saying, somewhere, so if I take into account this point here, right, and I take into account the point on the green graph, right, so that's having a value of roughly, so let's say minus zero point 0.4, for example, right, take away, right, roughly minus zero point 0.8, right, so that's going to lead us into a value of a positive 4, right, so that's how you can roughly work out these values, right? They don't have to be exact values because again we're trying to look at the graph and we're going to try and sketch as best as we can, right? Similarly, we're going to have a similar value at this particular point, right? Because the graphs are pretty similar position, right? And if I take into account these 2 points, right, 1 and 2, right? I've got a value of just about 0.4, zero point 0.4 minus roughly minus 0.4, so that's going to give us a positive 0.8. So somewhere there, right? So that's gonna, so let me just combine this graph with the curve, right? So 1, 2. As you can see, it is a really funny looking graph, right? So that's why it's really critical that you actually try and get as many points as you possibly can to get a more accurate picture of the combined graph of a half cos 2 theta minus sine theta, right? So I'm going to go straight into a graphing software, which is my TI Inspire calculator, and I'm going to try and draw this graph on the CAS calculator. So that way we'll be able to check our answers, whether we've done it right by doing it by hand. So I've opened up my CAS software. So I'm just going to open up a new document and I'm going to open a graphing page. Now we're doing circular functions, so make sure your calculator is in radians, otherwise it's not going to work. Right, so I'm going to go half times cos 2 theta. Obviously we can't use theta in our calculator, so I'm going to use x instead of theta. Right, cos 2 times x minus sine theta, so sine x in this particular case. Now, obviously, we have a restricted domain, otherwise, it's going to give us a graph from minus infinity to positive infinity. So I'm going to restrict my domain by doing control equals, right, the vertical bar, right, our graph is going from a minus pi, so you can actually type in pi, you can select the pi symbol, which is in there, right, again, I'm going to go control equals, right, is less than or equal to, right, x, and then somewhere equal to a positive pi, right? So that's why we restricted the domain from minus pi to pi. Right, and then press enter. Right, obviously, as we can see, that is pretty similar to the graph that we've actually sketched without the help of a CAS calculator. So if I go back to my graph, so you can see that's roughly the same. Obviously, given that we've done in really good depth in terms of the points, our graph's got a little bit more better shape than the one that the calculator's thrown up. All right. So that's pretty much where we stand with the addition of ordinates. So I hope that really helped you with sketching these functions. Thank you for